In this lesson, we're going to use the Gaussian elimination to solve a system of equations with four variables. So we're going to have w plus 2x minus y plus z, and that's going to equal 6. And then negative w plus x plus 2y minus z, and that's going to equal 3. And then we're going to have 2w minus x plus 2y plus 2z, and let's say that's equal to 14. And then w plus x minus y plus 2z, and that's equal to 8. Now the first thing we want to do is convert this into an augmented matrix. So the coefficients for the first equation are 1, 2, -1, 1, and then we're going to separate the left side from the right side with a vertical bar. So we're going to have a 6 on the right side. Now for the second equation, it's -1, 1, 2, -1, and 3. And for the third one, it's 2, -1, 2, 2, and 14. And then it's 1, 1, -1, 2, and 8. Now let's get rid of this. What we need to do is to convert these numbers into a 0. So if I add row 2 and row 4 and apply it to entry or to this row, I can get my first 0. So let's do that. So row 2 plus row 4, that's going to be the first row operation we're going to apply. So everything else will stay the same. So 1, 2, -1, 1, and 6. So that's row 1. Row 2 is not going to change. And row 3 is going to stay the same. So now we're adding row 2 and 4. So -1 plus 1 is 0. And then 1 plus 1 is 2. And then we have 2 plus -1, so that's 1. And then -1 plus 2 is 1. And then 3 plus 8, that's 11. Now the next thing I want to do is convert that into a 0. So I'm going to apply the next operation to the third row. And I'm going to use row 2 and 3 to accomplish that. So I'm going to multiply row 2 by 2 and then add row 3 to it. So row 1 is going to be the same. Row 2 is going to be the same. And row 4 will not change. So now let's focus on row 3. And let's be careful with the operations. So first, I'm going to write the row operation that I'm applying. So for the first column, row 2 has a value of -1, and row 3 in the first column has a value of 2. So -2 plus 2, that's going to give me 0. Now let's move on to the second column. Row 2 is 1, row 3 is -1. 2 plus -1 is 1. Now for the third column, row 2 is equal to 2, and row 3 is also 2. So we have 4 plus 2, which is 6. For the fourth column, it's going to be 2 times R2, which is -1, plus R3, which is 2. -2 plus 2 is 0. And for the last column, or the fifth column, R2 is 3, R3 is 14. So we have 6 plus 14, which is 20. Alright, now we need to make this a 0. So I'm going to apply the next operation to this row. And that operation is going to be R1 plus R2. Apply to the second row. So the first row is not going to change. So let's rewrite those numbers. And for the second row, let's not worry about that for now. The third row is going to be the same, and the fourth row will be the same as well. So all we need to do is add row 1 and 2. So 1 plus negative 1 is 0. 2 plus 1 is 3. And then negative 1 plus 2, that's 1. 1 plus negative 1 is 0. And then we have 6 plus 3, which is 9. So now, the next thing we need to do is make this a 0. Now, we don't want to subtract these two, because this will no longer be 0. So therefore, it might be wise to focus on row 3 and 4. So applied to row 4, I'm going to take negative 2 times R3 and then add it to R4. So let's rewrite the other rows. Now let's write the row operation, and let's be careful with every step, because if you make one mistake, that's it. The whole problem is basically ruined. So for column 1, R3 and R4 is 0. Negative 2 times 0 plus 0, that's going to remain 0, which is what we want. We don't want that 0 to change. Now, let's move on to column 2. So R3 for column 2 is 1, and R4 for column 2 is 2. So we have negative 2 plus 2, so that gives us the 0 that we want. Now, for column 3, R3 is going to be 6, and R4 is 1. So negative 2 times 6 is negative 12 plus 1. That's going to be negative 11. Now for column 4, R3 is 0, and R4 is 1. So this is just going to be 1. And then for the last one, for the fifth column, R3 is 20, R4 is going to be 11. So we have negative 2 times 20, which is negative 40, plus 11, that's going to be negative 40 plus 11 is 29, negative 29. Now the next thing we need to do is make this a 0. So let's get rid of this first. And I'm going to apply the changes to the third row. And I'm going to take R2, which is 3, and then add it, actually subtract it by negative 3 R3. So this will be negative 3 times 1. So it'll be 3 minus 3, and that will be 0. But before we do that, let's write everything else. So we have 1, 2, negative 1, 1, and 6. And then row 2 is not going to change. And row 4 is going to stay the same for now. So the operation is R2 minus 3 R3. So for column 1, where everything is 0, this is going to stay 0. For column 2, we can see that R2 is 3, R3 is 1. So 3 minus 3 is 0. For column 3, R2 is 1, and R3 is 6. So we have 1 minus 18, that's negative 17. So for column 4, everything is 0. R2 and R3 is 0, so that's going to stay 0. For the fifth column, R2 is 9, R3 is 20. So we have 9 minus 60, which is negative 51. Now, I do need to fix something because I had a 1 here, but for some reason I put a 0. So let's make that correction, and this should be a 1. So now, all we need to do is turn this into a 0. And we have to use row 3 and 4 such that these zeros are not affected. So what do you think we need to do so that we could cancel 17 and 11? So first we need to apply the changes to the 4th row. And so we need to multiply this by negative 11. So it's going to be negative 11 R3, and then multiply this by 17 plus 17 R4. So this value will be positive and this value will be negative, and they will cancel out. So first, let's rewrite the new matrix. It's going to be 1, 2, negative 1, 1, and 6. The third row and the second row will be the same. But the last row will change. So if we plug in these two, for R3 and R4, this will stay 0. And for column 2, it will still stay 0. But for column 3, it's going to be negative 11. R3 is negative 17. And then plus 17 R4, which is negative 11. So these two will cancel and give us a 0. Now, for column 4, R3 is 0 and R4 is 1. So this is just going to be 17 times 1, or 17. Now for the last column, we may need a calculator. R3 is negative 51 and R4 is negative 29. So negative 11 times negative 51, that's 561. And then 17 times negative 29, that's negative 493. So 561 minus 493 is 68. So notice that we now have the zeros that we wanted. At this point, we can convert back into a system of equations. Let's get rid of the matrix. So this is W, X, Y, and Z. So we now have 1W plus 2X minus Y plus Z, and that's equal to 6. Now for the second equation, it's going to be 3x plus y, and there's no z, so we could ignore that. It's 0z, and that's equal to 9. And then after that, it's negative 17y, which is equal to negative 51, and then 17z is equal to 68. So we have everything we need in order to calculate x, y, and z. Now, if you want to convert this to row echelon form, what you need to do is, actually, you know what? Let's do that. Because we could solve it now, but let's go ahead and convert it to row echelon form. So we don't need to multiply the first row by anything. The second row, I'm going to multiply it by 1/3 to make this a 1. And then the third row, I'm going to multiply it by negative 1 over 17. And then row 4, I'm going to multiply it by positive 1 over 17. So it's going to be 1, 2, negative 1, 1, and 6. Then it's going to be 0. And then 1/3 times 3 is 1. This is going to be 1/3. And then that's going to be 0. This is going to be 3. Then this is going to be 0, 0, 1, 0. Negative 51 divided by negative 17 is 3. And then 0, 0, 0, 1. 68 divided by 17 is 4. So this is going to be x, y. Actually, no, that's not x. That's w. So w, x, y, and z. So now let's write the equation. So it's going to be w plus 2x minus y plus z is equal to 6. And then we have x plus 1/3 y is equal to 3. And then 1y is equal to 3. And then z is equal to 4. So once you have the row echelon form, notice that we got some answers. We got z, and we have the value of y already. So y is 3 and z is 4. Now, let's calculate x. So let's take y and plug it into this equation. So x plus 1/3 y, or 1/3 times 3, is equal to 3. 1/3 of 3 is 1, and 3 minus 1 is 2. So x is equal to 2. So now that we have x, y, and z, let's calculate w in the first equation. So it's going to be w plus 2x, or 2 times 2, minus y, which is 3, plus z, which is 4. So 2 times 2 is 4, negative 3 plus 4 is 1, and 4 plus 1 is 5, and 6 minus 5 is 1. So w is equal to 1. So we can write the answer as 1, 2, 3, 4 in the form of w, x, y, z. So now you know how to solve a system of equations with 4 variables using the Gaussian elimination and reducing it to the standard row echelon form. Not the reduced row echelon form, just the regular row echelon form.